Hi guys, this is IGCSE O-Level Chemistry, paper 22, November 2020, question 11. The relative atomic mass of chlorine is 35.5. When calculating relative atomic mass, which particle is the mass of a chlorine atom compared to? Well, the definition of the relative atomic mass is the mass of an atom compared to 1/12 the mass of a carbon 12 atom. So it is compared to a carbon 12 isotope. So the options are a neutron, no, a proton, no, an atom of carbon 12, yes, an atom of hydrogen 1, no. Therefore, option C is the correct option for this question. Question 12. Universal indicator solution is added to a neutral solution of concentrated aqueous sodium chloride. So this would give a green color because universal indicator at neutral pH it appears green. The solution which contains hydrogen H positive, Na positive sodium chloride, Cl negative and hydroxide OH negative ions is electrolyzed. Okay. The product at the cathode is hydrogen gas and the product at the anode is chlorine gas. So if we have chlorine and hydrogen being eliminated, we are left with Na positive and OH negative, which would produce NaOH. So the what happens to the color of the indicator in the solution during electrolysis? So the solution becomes basic and appearance of universal indicator under the basic pH is blue or purple. So either of these two colors would be the color observed when electrolysis takes place. So the color changes from blue to green? No, the exact opposite. The color changes from blue to red. Red is acidic conditions for universal indicator. We do not have that during this electrolysis process. So incorrect. The color changes from green to blue. Yes, it was originally green. It turned to blue when NaOH was produced. And the color changes from green to red. Red is not involved in this process because there is no acidic solution being produced. Therefore, the correct option for this question is option C. Question 13. What is the empirical formula of an oxide of iron formed by reacting 2.24 grams of iron with 0.96 grams of oxygen? So we need to find the empirical formula. We have iron and oxygen present. The mass of iron is 2.24 and the mass of oxygen is 0.96. We would divide 2.24 by 56, the AR of iron, and 0.96 by 16, the AR of oxygen. So dividing 2.24 by 56 gives us a value of 0.04 and dividing 0.96 by 16 gives us a value of 0.06. So now we divide these by the smaller value out of these. So this would be 0.04. So we divide both the values by 0.04, giving us a value of 1:1.5. Next, we would convert this into whole number by multiplying both these values by 2, ending up with a value of 2 for iron in a molar ratio with 3 for oxygen, making the empirical formula Fe2O3. And this makes option C the correct option for this question. Question 14. The combustion of methane is exothermic. Which statement about this reaction is correct? The energy needed to break the bonds in methane and oxygen is greater than the energy released in making new bonds in carbon dioxide and water. So that would make this an endothermic reaction, not an exothermic reaction. Next, the energy needed to break the bonds in methane and oxygen is less than the energy released in making new bonds in carbon dioxide and water. That makes this reaction exothermic, which is correct. Next, the energy released in breaking bonds in methane and oxygen is greater than the energy needed to make new bonds in carbon dioxide and water. Energy is needed in breaking the bonds, and energy is given off or released when new bonds are formed. So this statement is incorrect. Next, the energy released in breaking bonds. The energy is needed in breaking bonds. In methane and oxygen is less than the energy needed. So here it would be an energy released to make new bonds in carbon dioxide and water. So this makes option B the correct option for this question. Question 15. Hydrogen reacts with oxygen in a fuel cell. The reaction is exothermic. 286 kilojoules of energy is released for every mole of water formed. Which volume of hydrogen gas measured at room temperature and pressure would react with oxygen with the release of 7,000 joules of energy? So first we need to calculate the number of moles of hydrogen that are present. So this would be 7,000 joules divided by 286 kilojoules, which would give us a value of 24.476 moles. So we have found out the moles of hydrogen gas. So now after finding out the moles of hydrogen gas, we would this should be 286,000. So this should be 0.024476. 0.024476 moles. This is because the energy release is in joules and the 286 value is given in kilojoules. So we convert both into joules. So this will give us the number of moles of hydrogen gas. Now, 1 mole of any gas at RTP occupies a volume of 24,000 centimeter cube, since the values are given in centimeter cube and dm cube. So the number of moles we have is 0.024476. So this would give us a volume of 0.024476 multiplied by 24,000, which would give us a volume of 587 centimeter cube. So this makes option A the correct option for this question. Question 16. Which substance does not require oxygen in order to produce energy? So we have coal. Coal is burned in oxygen in order to produce energy. Hydrogen. Hydrogen burns in oxygen exothermically in order to produce energy. Natural gas. Natural gas is also burned in air, which contains oxygen in order to produce energy. Uranium. Uranium is radioactive. It does not need oxygen to produce energy. It undergoes radioactive decay. So the correct option for this question is option D. Question 17. Nitrogen and hydrogen can be converted into ammonia NH3 using a catalyst. What is the purpose of the catalyst? To increase the amount of ammonia produced, a catalyst has no effect on the yield of a particular reaction. To increase the rate of reaction, yes, that is the purpose of it. It increases the rate of reaction by providing an alternate pathway, one having a lower requirement of activation energy. So this is correct. To reduce the amount of reactants needed, no, it will have no effect on the amount of reactants needed to form the product. To reduce the rate of reaction, that is not the purpose of a catalyst. The purpose of the catalyst is to increase the rate of reaction. Therefore, the correct option for this question is option B. Question 18. Ammonia is produced by the Haber's process. The equation is shown. The forward reaction is exothermic. Which statement is correct? Increasing pressure decreases the yield of ammonia but speeds up the rate of reaction. So increasing the pressure. An increase in pressure favors the side with the lesser number of moles. So the number of moles of reactants are 3 plus 1, 4, and the number of moles of products are 2. So increase in pressure will increase the yield of ammonia, but it will not have any effect on the rate of reaction. Next, increasing the temperature decreases the yield of ammonia. Because the reaction is exothermic, increasing the temperature will favor the backward reaction, which would decrease the yield of ammonia, but speed up the rate of reaction. Yes, because an increase in temperature increases the kinetic energy possessed by the reactant molecules. So the frequency of collisions increases, which includes the frequency of effective collisions, meaning the collision that result in product formation. Therefore, it speeds up the rate of reaction. This is correct. Next, increasing the concentration of hydrogen and nitrogen results in a lower yield of ammonia. If the concentration of the reactants are increased, the forward reaction would be favored, increasing the yield of ammonia. So this statement is incorrect. Increasing the temperature increases the yield of ammonia and speeds up the reaction. The temperature when increased will favor the backward reaction, so the yield of ammonia would not increase, it would decrease. However, the rate of reaction would be speeded up by increasing the temperature. So half of this statement is correct. Therefore, the correct option for this question is option B. Question 19. During the manufacture of sulfuric acid, sulfur dioxide is converted to sulfur trioxide. What type of a reaction is this? A displacement reaction. Nothing has been displayed. Oxygen has been added onto SO2. Neutralization reaction. SO2 is an acidic gas. O2 is a neutral gas. So neutralization is not taking place. Oxidation. So the oxidation state of sulfur in SO2 would be, we have two atoms of oxygen, so or two oxide ions, so 2 negative into 2 is -4. So in order to balance the charge, the oxidation state of sulfur would be +4. And in SO3, the oxidation state of oxide ion is -2, so total -6. And in order to balance the negative charge, sulfur would have a charge of +6. So +4 going to +6 is oxidation. So yes, oxidation is correct. And thermal decomposition, there is no decomposition taking place in this reaction, making option C the correct option for this question. Question 20. The equation for a redox reaction is shown. 2 moles of FeSO4 plus chlorine plus sulfuric acid gives Fe2SO4 thrice and 2 moles of HCl. Which element is reduced? Okay, so we have FeSO4, iron has a charge of +2. We have chlorine with a charge of 0. On the product side, Fe2SO4 thrice, iron has a charge of +3. That means Fe2 plus was oxidized to Fe3 plus, and chlorine in HCl has a charge of -1. That means chlorine gas was reduced to chloride ions. So the question is, which element is reduced? Chlorine is reduced to Cl minus ion. Iron is oxidized to Fe3 plus. Oxygen, there is no change, and sulfur also there is no change in state. Therefore, the correct option for this question is option A.